Hello and welcome back to another Craig and Dave Unscripted. So something a little different for you today. Dave and I receive dozens of emails on a daily basis, and not just from teachers, quite a lot from students. Now, I'll be honest, a good 95% of them are silly little emails. The number of weddings and birthdays we've been invited to, and I'm sorry, it's not appropriate. We're not attending your weddings or birthdays. And I mean, some of them I get. We prefer you, Craig, Dave, not so much. I'm like, thanks for letting us know, things like that. But yeah,
you are joking. I think, Craig, the truth is, it's big up, Dave.
I don't know what emails you've been reading, but anyway, joking aside, yeah, we receive a lot of emails from students, but most of them are just little silly emails. But occasionally an email comes along that really piques our interest, and we've had one of those such things. I think it actually came in before Christmas. Dave is going to lead on this, but we actually received a full-blown fan game by a couple of people there called Joe and Isaac. They'd made a game and sent it in. Now, I've not actually looked at it or installed it and played it. Dave has and said this deserves a Craig and Dave Unscripted video. So I'm going to hand over to Dave. This is as new to me as it is to the audience. I'm quite keen. What is it, Dave? And why is this worthy of an unscripted video?
Yeah, okay, thanks, Joe and Isaac. This is Craig and Dave Go Racing. So let me just bring it up on the stream. So we love this because it's exactly the sort of things that students do in the classroom. Our students do this in the classroom. They've taken a couple of photos of us and they've cropped it down and they put it on the little kiddie buggies and created a little game. It's absolutely fantastic. We love it when students do this kind of thing. I know some teachers get a little bit offended when they sort of crop their teacher's photo and do things with it. I mean, we embrace it. We love having fun with students. It's one of the best parts of the job. So yeah, now because of the way the game has been made, I can't easily show you the title screen because of switching in the sort of stream screen sharing, etc. It's very, very tricky, but it shows a title screen, Craig and Dave Go Racing, with a countdown timer, sort of 5, 4, 3, 2, 1, and then it presents you with this screen. Okay, and it's very, very simple. I mean, all you've got to do is get to the end of the road first. Whoever gets to the end of the road first.
What are my keys? What are my keys?
It's a button smasher, right? So you're on the right button and I'm on the left button, and okay. In fact, I'm just going to quickly test that. Yeah, I'm on the left button. Craig's caught me out. Craig's caught me out. And you basically smash the button as hard as you can, Craig. And whoever gets to the end first basically wins, right? That's what it's about. So we'll have a little go, and then what we'll do is we'll talk about this sort of style of game and its context, maybe for A-level projects and that sort of thing, and have a look at the code and we'll break it down.
All the boring stuff. Let's play the game.
Go, let's play the game. Let's play the game. Right, you ready?
Yep.
3, 2, 1, go. Come here. Come back. Come here. Come here. Whoa. No. Craig wins.
Showing that the younger person has a higher level of dexterity. Well, that's genius. It's the simplicity. But sorry, you did say they wrote this in Python, yeah?
Yeah, Python. Well, we can have
Pygame plugin. Okay.
Yeah.
Sorry, go on. I talked over you.
No, sorry. I was just going to say, yeah, Python. We can have a look at the source code and have a little look at it. Yeah. Here we go. Here's the program.
Yeah, there you go. Pygame. Yeah.
Import Pygame. So this is written in Pygame, so nice and straightforward, which is brilliant. We're also using the random library. I'm not quite sure why, actually. I don't think there's any randomness in the game, but so there's something. There's a little talking point there. So if you're including additional libraries that aren't going to be used, then that's not particularly memory efficient for your algorithm. It may well be that the code optimization process would sort of potentially strip that out, but not possible. Well, maybe it might do, but you've got a linker coming in after that that's linking in the libraries that it needs. So That's not great if that's the case, but it's okay. Then we've got time and system, and I guess we're using those for the countdown timer and whatnot. Okay,
Yeah.
so we've got screen height 600, 300, and then we load our images. So we've got some variables that are holding our images. So we've got Dave PNG, Craig PNG, back PNG, back to PNG, and those two are quite important. We'll talk about those more in a minute, back PNG and back to PNG. You've got the title, and then various little sort of, you know, logos and bits and pieces that it's loading into variables. So that's what that little bit there is doing. Okay, so if we scroll down a little bit, we're then setting up some variables. So we've got Craig's distance and Dave's distance, whether we're running the game or not, the number of clicks that Dave's made, the number of clicks that Craig's made, those kinds of things. Okay, and then we sort of set up the game environment. So we're setting a window. This is kind of how you do these things in Pygame. Set a window with the width and height. Set a caption on the actual window. That's what's displayed in the title bar.
Oh.
And then it draws the window. There we go. So it draws the window there. So that's obviously all in a procedure. So it hasn't actually done that when it's you know, before it starts running the main program. So then we get down to the main program. So it initializes Pygame. Starting 6, that's our kind of countdown timer variable. And then while starting is greater than 1, do this little loop where
this is, I guess this is the countdown screen you were alluding to that we couldn't show.
Yeah, exactly. So we're saying starting equals starting -1, so it's going to count down, and then it's going to basically put the title image and the logo, and then it's going to put the bit of text that it's created starting in, followed by the variable that is counting down. And what's interesting here is it's updating the display, and it's rewriting over the top those images and counting down. Otherwise, what you'll find is that you'll have the previous frame still shown. So it'll say counting down in 5, 4, 3, 2, 1, but you'll still see 5 when it displays 4. You'll still see 4 when it displays 3, and it'll all start to, you know, look a bit strange. So we're kind of re-rendering those graphics over the top, prevent that happening. We're sleeping for 1 second to enable the countdown timer to work, and of course when it's finished the loop, it then immediately kind of gets into the game. Now I could have doctored that code a little bit to make it easier for me to show you on the screen, but I've just left the code sort of as it was presented to us. So then we run the game, okay, and what we've got now is these 2 images, back and back to, that provide our scrolling background. And I think that's the bit that's interesting. We'll come back to that in a second. If we just go through the program a little bit more and ignore sort of where it's you know, drawing the background and the Craig and Dave little buggies, we've then got an if statement in there that says if Dave's distance is greater than 450, then Dave wins. And if Craig's distance is greater than 450, then Craig wins. And sort of it just kind of continues to go around that loop, updating the screen until eventually one of the buggies is on the right hand side of the screen, determined by the Dave dist and Craig dist variables. And we can see in the movement bit of the code there with that comment that you know, it's literally checking, have you pressed the left button or have you pressed the right button? If you've pressed the left button, increase Dave's distance by 5 and Dave's clicks by 1. And if you've pressed the right button, then increase Craig's distance by 5 and Craig's distance by 1. So we could introduce a little handicap there for Craig. we could increase Dave's distance and not so much Craig's distance, and have a bit of a handicap in there. That's what I should have done. That's what I should have done. I should have doctored the code before I let him see it.
And there's nothing, just before you talk about anything else, there's nothing massively complex here. A beautiful, simple game. I mean, it worked. I mean, it may be at your school you've not had a play with Pygame and looked at some of the graphical elements, but you know, looking at it there, you can kind of see. Sorry, you can kind of see what's going on. But beyond the Pygame elements, which may be new to some people, there's very little there. We've got variables, we've got assignments, we've got procedures, we've got while loops. You know, we're using booleans, if statements. Yeah, but a
Yeah.
nested if statements, like it's quite, fundamental skills. They've produced something that works. Simple, love it.
To be honest, Craig, I think any GCSE student should really be capable of this, because like you say, there really isn't anything in there beyond simple iterations and selections. The only thing that perhaps you might not, well, you won't have learned unless your teacher's taught you Pygame, is how you can get key events
Yeah,
using, if event.type equals pygame.keydown,
yeah,
and then seeing whether the key is left or right. But as you can see, it's a simple if statement. It's not very challenging. And this idea of bit blitting, which we won't get into the
yes,
theory of bit blitting, but basically the concept being that you can have a picture that you then display on the screen, and you just give it the coordinates of where you want to display that on the screen. So those are the only two little components there that make this beyond what you might have been taught in the classroom. Otherwise, it is simply variables, selections, and iterations. I mean, there's no arrays or files, well, files as in it loads the graphics, but not sort of, saving text files and things like that. So it's, yeah, this is very much in the realms of a sort of GCSE style project. And I think this is really good, because often students, they look at games and they think, oh, that is far too complicated. I have no idea how I go about that. But a lot of the time for simple games like this, it's really not that tricky. And it sort of reminds me, the reason I really like these kinds of games is it sort of reminds me of my youth. And I used to have a game called, I don't know if you remember this, Craig, Daley Thompson's Decathlon. Do you remember that?
yeah. It caused you just to smash the hell out of my Spectrum 48K keyboard. Yes, exactly.
Yeah, and it's literally, Daley Thompson Decathlon. You had to hit the left button, then the right button, and the left button, and the right button, although it might have been letters, I can't remember. But, left, right, left, right, left, right, left, right. And you have to do that as quickly as possible in order to get, Daley's legs to move. And the quicker you could do it, the faster he would run. And you'd have CPU characters in there that were obviously moving, according to variables. And you can make something like that really, really straightforward. I mean, we could easily increase the code in here, for example, to say it's not just every time you hit the left button, but after you've hit the left button, you have to hit the right button. And we just do that with a Boolean, has the left key been pressed, true or false, and only allow the left key to be, registered again if that variable is false, and reset it after you've hit the right button. So, an extra if statement there, and all of a sudden you've now got to press left, right, left, right, left, right. So
I'll tell you one thing
yeah,
I'm curious about, Dave, and I'm sure you can explain this. They've obviously made this work very simply, and scrolling through the code, I couldn't see it instantly. But even my A-level students struggle sometimes with something as simple as a scrolling background.
yeah,
But they've got it in there. We've got this constant moving
yeah,
scrolling background, nice and simply
yeah,
done. You've had a look at this. Have you got? I mean, how have they
yeah.
done that?
Yeah, I've actually prepared just a 2-slide PowerPoint that explains how that works.
Okay.
But you're absolutely right. Often the solution is not as complex as you think it's going to be. Now,
Yeah.
scrolling backgrounds can be done in lots of different ways, and I'm not going to advocate that this is perhaps the best way of doing it in terms of efficiency, because it will put, the way this has been done puts quite a lot of load on the processor or the graphics card, but it works, right? And it's absolutely perfect for both GCSE and A level.
Okay.
You probably wouldn't take this approach with a professional game, but it works and it's absolutely fine. So let's just have a look at this. Yeah, so here we go. So this is the title screen that you didn't see because of the way it was
Right.
coded. It was difficult for me to do that, although I could have increased the time and we'd have got away with that. That would have been fine. Anyway, what you've actually got is the green part of the picture there on the title isn't part of the picture. What Joe and Isaac have done is set the background color to green, and then they've put the picture that's got sort of transparent background over the top of that. So that's
Right.
how that works. That's called title.png. Then you've got some extra images. So you've got back.png and back2.png. And those two images are
Okay.
exactly the same. It's just a copy of the image and they've changed the file name. And then you've got Craig.png and Dave.png, which obviously they've put together in a little graphics application. So there are a couple more little logo graphics and whatnot, but this is the heart of what we're looking at here. So it's just some simple graphics files And then the scrolling background, which is the interesting part. So what you've got here is, imagine time going down, and the screen space that you can see I've represented with a sort of blue box. And you can see that when the game starts, you see the back image, okay? And the back two image you don't see because it's kind of off the screen to the right. It's still rendered, but you don't see it because it's off the screen, as it were. And this is why I say you possibly wouldn't do it this way with a real commercial game, because you're rendering something that's off the screen and it's quite a large image, and you know, you'd get performance issues with that, but it's fine for a game like this. And then you can see as time progresses, as we go down, what's happened is we've changed the X position of both the back image and the back two image, and we've subtracted that so that the back image now is rendered slightly off the screen to the left, and the back two image is rendered slightly to the left of where it was before. So we're just decrementing a variable basically to achieve that. And so you can see over time how back is slowly shifting off the left hand side of the screen, and back two is slowly shifting, you know, from the right hand side of the screen onto the screen. So you get this impression and this illusion of a scrolling background. And of course, what happens is eventually you get back being completely off the screen. So it's off the screen to the left, and all you're seeing at that moment in time is just back two on the screen. And what you do then, before you kind of move sort of back and back two again, is you just reset the X position of the back image to be what the X position of the back two image was when it rendered for the first time. So you just have another variable that just holds kind of where it's got to not even respawn, because it's not despawning and respawning.
It's just
all
moving,
it's doing
yeah.
is it's changing the value of the X variable.
I've been looking at the code. I know our viewers can't see that. I've been looking at the code as you've been talking. So excuse my. So this is what's going on here, isn't it? If back plus 2 is minus 600, reset those X coordinates to 600, and likewise here for the other image. So that's what they're doing. Beautifully simple.
Yeah,
beautifully
really beautifully simple. And this is very typical of the kind of analysis we'd want to see at A level. It's the kind of things that actually students struggle with, if I'm honest, and they struggle with it because they haven't experienced it before. They've experienced it in terms of playing games that have a scrolling background, but they haven't thought about, well, how could I achieve that? And students at A level get stuck because they're not able to see what the potential solution is. And well done to Joe and Isaac for spotting that actually we can achieve this if we have two images and we just change the X value of those images over time. The solution is elegant and simple, and it works. And it's the kind of problem decomposition I'd really like our A-level students to be able to do. Yeah. So how do we get them there? I guess that's the question. And it's just about sharing with the students, you know, different games and talking about different approaches and things that you could do, and ways of going about it, and then letting them explore and discover for themselves.
I know we're sort of going off at a tangent a bit now, but we're only at 18 minutes. We do tend to go a bit longer, so I don't mind at this time. But you're right. It's how do you get students to that place where they can break things down, you know, see solutions outside of their current understanding? And I was liking it to the very first time. I don't know if you get this, that the very first time I ever introduced students, either at GCSE or A level, to the idea of swapping the contents of two variables over. If they haven't thought about it before, a lot of them get stuck. They get stuck. Well, I've got variable contents here and variable contents here. I want these to go there and there to go. How do I do that, guys? I want to swap them. No. Computer's doing one line of code at a time. What do you want to happen? Well, I want to put this in there first. Okay, cool. So what's in there's gone now. So we've got two copies of that. So, and they're stuck. And I try and ease it out. And once they understand, well, hang on, I'll introduce a third temporary variable. I'll just store this over here temporarily, then move that across, then move that. You know, as soon as you introduce that, then they go, then it's obvious, then they click. And you know, I always hit that quite early on, and we use that temporary variable thing, swapping items over quite early on in the course sometimes. But every time they get stuck, because of course, how do we do it as humans? We go, well, I I'm just going to put that in that and that and that. I'm just going to swap it. It just works. And it's getting past that. Have you got another solution? Can you think outside the box? I can't do that because now I've got 2 copies of this item. That doesn't work. Oh, I don't know how to do it then. No, you don't know how to do it yet. Stop. It is an interesting step, isn't it? And getting students there through GCSE and A level, thinking outside the box, being analytical, not giving up when you hit the first hurdle. I think that is half the challenge of being a good programmer.
Exactly. It's about going beyond the I don't know how to code this, which of course you don't because you've got no experience of it, to but what do I actually want to happen? And sort of modeling that with pieces of paper, for example. We could have drawn a background on 2 pieces of paper and said, well, look, it could work if it's like this. So how am I going to achieve that? And it's seeing those solutions, not seeing code, but seeing the solution. Because if you can see the solution, then the code falls out of that. And it does take experience, I get that, and it's not an easy skill, which is why, you know, analysis and design is so important. So yeah, I mean, you know, a little extension of that could be, well, how do we get some parallax scrolling in then? So for example, the road is scrolling, so we give them, that's the other thing, that, you know, it's not the buggies that are moving, it's the road that's moving, and it's fine for an illusion because it doesn't matter, does it? And that's sort of, you know, almost abstraction there. You know, what matters here? What matters here is that we've got the impression of movement, but it doesn't have to be the buggies that necessarily do the moving on the road. It's the road here that's moving, which isn't, of course, what happens in real life, but it doesn't matter.
Doesn't matter.
It's abstraction, right?
Yeah.
And so we could introduce some parallax scrolling where we've got the road sort of independently scrolling of the sort of the trees in the background. How would we achieve that? Well, again, if I was to pose that sometimes to some of my students, they get stuck and say, I don't know. Well, how does it work in this game? Oh, we've got 2 images, we change the exposition, we swap it when it gets off the screen. Yeah, okay. Well, how are you going to do your parallax scrolling then? Well, what if I had an image for the road and a separate image for the background rather than it all being on one image? Right. So now you can just move 2 images completely independently. And if the image in the foreground is moving quicker than the image in the background, then you get this kind of parallax scrolling effect. So it is getting the students to just see a little bit beyond and a little bit further, and just take what you've already learned and just take that to a new place. It's not something new to learn, just take what you know now to a new place. And it's incredibly hard to teach. I'm not going to deny that.
It's to all the students watching, that's a real key right there in a nutshell to being a good programmer. If you only take in every single specific skill or specific new technique that you're taught, then that's fine. But the real skill comes in you during that lesson or after lesson at home thinking, I've learned that. I wonder if, and then giving it a go. That's what I learned as a programmer. Oh, I've learned that. I wonder how I would do this. I wonder if I'm just going to have a go. Sometimes you'll get there. Sometimes you'll hit a brick wall. Sometimes you'll try a solution. You'll go down a rabbit hole. You'll come back out. You'll try something else. But that is where the real kind of like expansion, if you go, because that's where all that, you know, analytical thinking goes on. You can just learn the specific skills and techniques and complete the exercises that the teacher sets, and you know, you have a reasonable competence in programming, possibly to the level required for your exam. But beyond that ability to be analytical and go, I've learned that bunch of stuff and I've solved the problem the teacher did, but what else could I do with that? It's at that point where you really start to make those links, and I think you really kind of step up as a programmer, and it will help you no end in your exams if you've trained your brain to think like that.
Yeah, and that's where Joe and I have excelled. You know,
absolutely.
they've learned how to do variables, they've learned how to do a selection, they've learned how to do an iteration, and they've learned how to put graphics on the screen. And those are the only things they needed to learn. And they took that knowledge and then they applied it to a problem that they wanted to solve. And that's what I really like about this. Anyway, Craig, I think we're just about done, but I think Joe and Isaac probably deserve a little gift. Would you agree?
Didn't run this by me before Unscripted. Look at that, I'm on the spot now. Yes, of course they do.
Of course they deserve a gift. But what we don't have, Joe and Isaac, is your real email address, and we don't have your physical addresses if we were going to send you a gift. So if you want a gift, and you don't have to have a gift, but if you want a gift, can you please send us another email that's got your full names and addresses, and then we can get in touch with you and get a gift off to you. How about that?
Yeah, happy to do that. No, brilliant. So once again, thank you very much to Joe and Isaac. Brilliant, love that. And I think you'll probably just finish by saying, if you are doing anything similar to Joe and Isaac, I'd love to send this off. Please feel free. I think a little caveat there. Please make sure that we have the source code. Preferably write it in Python or Pygame or something like default. VB, C#'s all good, but we need to be able to run it. We need to be able to see the source code. I'm just going to be honest. If we start getting email attachments that just have mygame.exe, I'm not downloading it to my desktop and running it. That's just common sense. We need to see the source code for safety reasons, and also because we're then going to want to talk about it and then show it. But we've loved receiving that from Joe and Isaac, and we're happy to receive similar things in the future. Next week, guys, we're going to have a look at another resource that dropped a few weeks ago, and we told you we'd talk about it. We're going to talk about our new version 2 of Telium, which is our text-based adventure game that's available to premium subscribers. But until then, thank you very much, everyone, and goodbye for now.